Hey, what's up guys? Welcome back to Josh Does Coding. In today's video, we are going to be continuing on with our wave-based survival, and we are going to be creating logic for the enemies to chase the player. With that said, let's hop straight on into it. So, the first thing we're going to want to do is open our enemy character. So, to actually get the enemy to chase the player, it's going to be very simple. So, in our game, we really have simple AI, so we don't need to worry about using more advanced AI logic like blackboards. We can actually just call AI move to, and this is all we need. So for the pawn, we can just get a reference to self, and then we aren't going to use a destination. Instead, we're going to use a target actor, and this will be the player character, so we can just call get player character. And the reason we aren't using a destination is simply because if you're using a target actor, you don't need a destination, since the target actor is essentially setting the destination to its location. The acceptance radius is how close the AI is going to try and move to the player before it considers the move successful. So it's going to try and get within 5 centimeters of the player. We can always increase this or decrease this later on, depending on how it feels, but for now, I'm just going to leave it like that. And frankly, we're done. The AI can now chase the player. But there is one more thing that we're going to want to do. So in our specific level, we have these ramps going up around the map. Now, we can obviously get rid of whatever we want in this level, but it's safe to assume that at some point in your level you're going to want some sort of slope. Now, the problem with this is that our AIs, their root component, if you take a look here, is actually right around their waist. So if they were to spawn on a slope, they'd actually spawn like this, and then they'd not be able to move. So we need to address that issue. And the way we can do that, if we open up our enemy blueprint, we're going to come to our begin play. We're going to come right over to the end. We are going to do actually, we're going to create a function, and we're going to call this align enemy to ground. Now, in the future, we can also make it so that when an enemy is walking down a slope, we can rotate it slightly so it actually looks like it's walking down a hill. But for now, we will just set the location for this alignment. To do that, we will do a line trace for objects. And what this is going to let us do is check where the enemy is spawning and adjust the location accordingly. So we will call get actor location, which will give us the location of our enemy. And if we right click this return value, we can split this struct and we'll get the x, y, and z values because these are vectors, which means it has an x, y, and z value. We'll want to do the same for the start and end pins on the line trace for objects. So for the x's, you can just hook them up directly. Same for the y's. Before the z's, what we're going to want to do is drag out and do z plus, we'll say 500. And then we'll do z minus 500. Just like so. So what we're doing is we're getting the location of the actor, and this will be called on begin play. So it's going to be where the actor spawns. We're going to check 500 centimeters above it, 500 centimeters below it, and see if we can align ourselves to the ground accordingly. Now, if you're working on a level where it's multi-leveled, so like maybe a parking garage or an apartment building or something, you probably don't want to add the plus 500. Maybe just do like plus 50 or something to get the head level. But we don't have to worry about that in this specific example, so I'm just going to leave it at a general 500 to make sure it's big enough. Now for the object types, we can drag out and do make array. And by default, it sets to world static, which is exactly what we want. We want to check for static actors in the level because that is all the cubes that make up our level. Everything else we can just leave defaulted. Now we have a Boolean return value, which we'll drag out and do a branch. So basically, we're just checking if we hit something, and it is almost certain in this particular case that we will hit something. So we don't have to worry about doing anything on false. And if true, we're actually going to drag out our out hit and call break hit result. And we can do set actor location and hook that up to our true branch. So this is the location where the trace hits. And what we're going to do is we're going to drag out and then call break vector. Once again, we're going to right click on the new location and we're going to split it. We'll hook up X and Y just like before. And this time we'll do Z plus 50. And the reason for this, instead of just setting it to the location, is as I mentioned, the root is right about here, which means we will want to actually move it up 50 so the feet are around here as opposed to the legs. And that's just to make sure it doesn't get stuck in the ground when it spawns. So now on begin play, we can just call align enemy to ground right at the end. And if we compile and save this and we run our game, you'll now see we successfully have enemies chasing us around the map. None of them are getting stuck in the ground. They're spawning perfectly fine. Now in your specific level, if your enemies are getting stuck in the ground, feel free to increase it from plus 50 to plus 100 until you find a value that works for you. In the future videos, we can look at a more advanced way of doing this if we run into any future issues, but for now, this seems to be working fine. Now the one last thing we can do is that we can adjust the speed at which the enemies move. So right now you can see they actually move just as fast as the player does, which we don't want. Maybe you do, and if you do, that's great. You don't need to adjust the movement speed. But for me, I want my basic enemies to be slower than the player. So I'm going to open the base enemy. I'm going to come to the character movement component right here at the bottom. In the details panel, there is a character movement walking section where you can set the max walk speed. Now, by default, this is going to be 600. I'm not sure. It's going to be 600 centimeters. I'm going to set this to 300 centimeters. Though it's defaulting to meters a second. Maybe. I'm not sure why it's doing. Why it's defaulting to meters. But I guess I can just do 30 then, which will make it, or sorry, we'll want to do just 3, which will make it there you go. Now it's doing centimeters a second. Now it's doing meters. I guess 3 meters a second is fine. That's 300 centimeters a second, which is what we want. Honestly, I'm not sure why it was doing that. So just keep an eye out. It's very important when you work on movement if it's saying meters a second or centimeters a second. Honestly clueless as to why it just did what it did, but we'll move on. So now you can see the enemies are moving half the speed the player is, because the player is also by default using that 600 centimeters a second value. And now you can run around, shoot your enemies as they chase you, and we are slowly putting together a game here. So that's going to do it for today's video. If you did enjoy it, be sure to leave a like. In the next video, we are going to be making it so that the enemies can attack the player. So if you do want to see that, be sure to subscribe. Also, be sure to leave a comment down below if you have any questions or if you have any suggestions on how I can improve this series going forward. With that said, I hope you guys have a great rest of your day and good luck with your games.